Welcome to the Terminology Leading Practices stream of SNOMED CT Expo 2022. My name is Mark Bank. I'm a map specialist, terminologist at SNOMED International. I'll be moderating today's session. All questions will be answered at the conclusion of the presentation. For those online attendees, please use the Q&A box to type your questions to the presenter. On-site attendees, please use the microphone provided. I'm now pleased to introduce Soo Kyung Huh from Yonsei University Health System Severance Hospital, who will be presenting automatically mapping SNOMED CT to Korean clinical terms using cross-language semantic matching deep learning algorithm. Soo Kyung, please proceed.
Thank you very much for the introduction. Hello, my name is Soo Kyung Huh, and I'm currently working as Health Information Manager in Severance Hospital in South Korea. So currently we are in the process of mapping SNOMED CT to various fields of clinical terminology that are used in our hospital. So for today, I'm going to talk to you about how we are doing about automatically mapping some of the clinical terms to the SNOMED CT using a cross-language semantic matching algorithm. So in August 2020, South Korea became the 39th member of SNOMED International in the expectation of achieving the standardization of medical terminology and for promoting various medical research and healthcare services. So since then, there have been numerous projects promoting the implementation of SNOMED CT. So some of the examples includes the certification of electronic medical record system, which recommends the SNOMED CT as the terminology standard. And like the data-driven hospital project, which is driven by the government for promoting usage of medical data. And one of the tasks include the terminology standardization. So these kinds of various projects really encourage the medical institutions in South Korea to map their local terminology into SNOMED CT. Oops, sorry. Okay, so looking into the current status of medical institutions in South Korea, around 60% of the diagnosis terminology is mapped to SNOMED CT, and about 53% of the operation terminology is mapped to SNOMED CT. So, however, in comparison, the mapping rate is lower for other fields of terminologies like examination, nursing, and etc. It's much less. This was sourced from the SNOMED CT related survey conducted in 2021. So to help the mapping process, the Korean Health Information Center released various SNOMED CT maps with researchers, including Korean Standard Classification of Disease, which is the Korean version of ICD-10. And electronic data interchange codes to SNOMED CT, which is the insurance code for the procedure and medical behaviors. So these kinds of SNOMED CT maps definitely encourages precise mapping of SNOMED CT, and it reduces time and effort that takes into mapping. So Severance Hospital is located in South Korea and is one of the largest hospital in in the country. And we have been promoting standardization of medical terminology from the start of our electronic medical record system. Our electronic medical record system was opened in 2005 in Severance Hospital. And the clinical terminology master database was also created within that system. And we also have committee for the terminology standardization and the subcommittee of data standardization, data quality, and the common data committee. So the overall committee's goal is to establish the standard for terminology and the clinical records management, and the committee deals with matter concerning with the mapping and criteria of terminology classification system. So we have a meeting quarterly to discuss the current status of our standardization and the problems concerning with that issue. So Severance Hospital have been mapping SNOMED CT and managing the map of diagnosis and surgery terminology since 2005, which is the start of our EMR system. And due to the data-driven hospital project of government and the standardization, common data model research, and other clinical researches, standardization of various fields of clinical terminology in the hospital is in the progress. Currently, examination terminology is being mapped to SNOMED CT, which is one of the most commonly used terms in the hospitals. So this terminology is important because given that the important examination such as imaging, pathology, and those kinds of terminologies can be utilized for research after the standardization. However, there are some obstacles when mapping examination terminology to SNOMED CT. The examination terminology is composed of both Korean and English terms, that it makes difficult to search by SNOMED CT terminology. And there are many medical abbreviations used in examination code that the data needs to be cleaned beforehand. Also, even though the examination terminology is mapped with some electronic data interchange code, the EDI SNOMED map allows only about 30% of mapping, so making the mapping process difficult and time-consuming. So in addition to the mentioned issue, there are 3 severance hospitals in different regions. So one in Sinchon, Gangnam, and Yongin. That even though the terminology used in each hospitals are standardized and share same master database, there are some different characteristics like the patterns of terminology usage and such. And if the mapping process is conducted in each hospital, there could be a problem with the standardization of SNOMED CT mapping. So to laying out the current problem, it is difficult to map the severance hospitals examination terminology into SNOMED CT because the terminology is consisted both in Korean and English terms, that it needs the translation beforehand for mapping. So therefore, it takes quite a lot of time for mapping, and it requires experts' effort. So to solve this problem, we are trying SNOMED mapping through a natural language processing model using an algorithm that is capable of semantic interpretation. So basically, we are trying to do a auto mapping of SNOMED CT through NLP. So natural language processing is interactions between computers and the human language. In particular, how to program computers to process and analyze large amounts of natural language data. And we used semantic similarity measures, which is the task that measures the relationships between different texts using a defined metric. So we evaluated various model and algorithm for the semantic similarity measure task. We evaluated string-based Levenstein distance, corpus-based world embedding like word2vec, and corpus-based language model of BERT. So Levenstein distance, it's similarity measures between words. It calculates by counting the number of edits required to transform one string to another. Word2vec model is to shallow neural network, which is trained to recon. So to briefly explain the several hospitals examination terminology data, the terminology is classified based on the examination code group. It is classified according to the field of examination and the department which conducts the examination. And we arranged some of the classification and made A groups for the training. So these are the example of the examination terminologies. Also, the terminology database itself contains a lot of other metadata. So it has around 80 of them. So it's consisted with the data like insurance type, examination department, and such. So we selected some of the relating metadata to use for the training the model. So we went through data pre-processing step to improve the quality of the text, making it suitable for machines to process. So to summarize the process of the data pre-processing, the examination terminology was normalized by transforming medical abbreviation to the full term. Also, lowercasing and removing the substitutional or special characters was done. And after that, we created 3 data sets. The first is the original examination data set. Second is the data set that were translated to all English. And the last is the data set combined with metadata. And the data set were divided again according to the examination code group for the training. So in order to train the model, the training data is needed. So some of the data were mapped to SNOMED CT by the expert. So for the labeling process, first we mapped the examination code through the EDI SNOMED map and we confirmed the mapping. Second, we mapped the rest of the terminology and label the map from 1 to 5 based on the mapping type. So 1 would be the not similar at all, and 5 would be the best similar matching. So we used most exact mapping as 5, and for the broad or the partial mapping, we degraded the score for the train. So as explained earlier, we used BERT for this task. BERT is a transformer-based machine learning technique for natural language processing, pre-training developed by the Google. And we used sentence transformer. It's a Python framework for sentence, and it can solve classification or compute similarity score. So to explain in detail, 2 sentence pairs annotated together with the score indicating the similarity are trained, and the score ranges from 1 to 5. So we normalized it by dividing it to 5, since the cosine similarity ranges from -1 to 1. So once the sentences are embedded by the BERT, then is the pooling layer, which is some mini aggregation that we used to generate UMV. And cosine similarity are computed between UMV, and we compared it with the label and trained the model. So we trained the various BERT model to choose the best model. We used a BERT that was trained on the large scale biomedical corpora and continued training on the our training data set in several hospitals. For better performance, we divided the training by the examination code group. So this is the overall pipeline of the process. We first did pre-processing of examination terminology data. And after pre-processing stage, 3 input data and training data set are created, ready for the training the model. After training the model, we evaluated the outcome and did the validation on the outcome material. So this is some of the example results of the outcome. You can see that some of the examination term in Severance Hospital is matched to SNOMED CT term. We are currently in the process of verifying the results. So in the case of functional testing, the mapping rate was about confirmed to be around 87%. So the validation is currently being done by the Health Information Manager and Medical Records team of each Severance Hospital. So we are validating how well the mapping outcome was mapped to SNOMED CT by evaluating 1 by 1. So also we are evaluating whether the best term has been mapped, and if not, see what would have been the best right mapping concept would have been. So also we are mapping the unmatched terms. So the outcome validation process is scheduled to be done until the October. So for the feedback potential to SNOMED CT, this study can be a reference for not only Korean, but other cross-language SNOMED matching studies. And the localization of SNOMED CT is being progressed in Korea. and the effective automatic SNOMED CT coding of Korean clinical term will help improve the value and the usage of Korean clinical data. The accurate translation of clinical term is still a challenge. Existing cross-language coding method goes through machine translation, but the quality of the translation affects the mapping. Also, there is some issue with the multilingual birds that those produce rather bad sentence representation out of the box. So nevertheless, the study devote the effort to automatically code SNOMED CT terms without translation. So when training the model, segmenting the field of examination showed better SNOMED CT mapping results because the same department or examination field shares similar abbreviation and examination terminology. It is easy for the model to proceed with training and thus produce good results. So I recommend to segment the training data according to the similarity of the terminology for the better mapping results. But there are also limitations in the study. First, this method requires quality training data. So in the process of labeling the training data, translating the Korean clinical terms into the English is necessary. So this process can be difficult since the SNOMED CT do not provide Korean SNOMED description yet. Also, good quality of mapping data can be only obtained by experts' time and effort. Second, it's difficult to map well for some infrequent terms. The infrequent terms cannot be trained well for the birds. So these infrequent terms are often unmatched and requires humans' attention. And third, validation process is necessary to figure out if the mapping has been done correctly. So the cosine similarity metric alone cannot be the sole validation metric. The NLP often requires humans validation, and in this research also, which is dealing with clinical terminology, it's necessary to evaluate it by the experts for the mapping. And for the further plan, as mentioned earlier, we are doing evaluation by the end of the October. So the function tests have been evaluated. It showed about 87%. And we are currently evaluating the other examination code group. And we are trying to figure out if the matching outcome could be improved. We are working on to create more accurate model that can outperform the previous algorithm. So we are looking into the maybe unsupervised cross-lingual semantic textual similarity, supervised cross-lingual sentence similarity methods. It relies on the existing parallel resources, and it can lead to a circular dependency problem. So we are planning to do a unsupervised cross-lingual STS metric using BER for the further study. That was it for my presentation. Thank you for your attention.
Thank you. Soo Kyung will now take a few questions while we've got a few minutes left. As a reminder, if you're in the room, please raise your hand and I'll bring the microphone round to you. So any questions in the room first? No. I'll give everyone a second online to type any questions. Okay, we've got one question online so far. So it comes from Jay Kohler. It says, great presentation. Agree with the governance process via terminology standardization committee. Two separate questions. Firstly, You've got good tensor scores for some examples you showed. Are there some categories or segments of entities that you had issues with?
For the pathology, because it was hard to map the pathology terminology, it produced a rather bad results. So that would be my answer. The pathology was quite hard to map.
And Jay's second question is, one challenge with using classifications such as ICD to SNOMED approach is that users expect more generic concepts than the more specific, detailed SNOMED CT concepts. And is that something you found?
I'm sorry, English is my second
Sure.
language. I didn't get the question.
So, I'll repeat it. It was one challenge with using classifications to SNOMED CT, so things like ICD map to SNOMED CT, is that the approach is that users expect more generic concepts, like you would get from ICD, rather than the specific detailed stuff that you would get from SNOMED.
Oh,
and is that something your users expected?
Oh yes, of course. We expect much more specific mapping, like for the SNOMED CT, or concepts like for the for much more ICD-10 cannot. We use our own local terminology, so the ICD-10 doesn't really represent well for all the terminologies that we create from the hospital. So SNOMED CT has better representation. It's much more specific, and it's much more for the research, like for the very small number of diseases, we always use SNOMED CT for the research.
Okay. I hope that answered your question, Jay. Jay's responded about labs and said, perfect. He was expecting you would mention labs and pathology. So he wondered if he could follow up with you about this and wondered if it was all right to email you.
Oh, sure. Yeah.
Okay. Perfect.
Please say.
And that's all we've got time for. Thank you very much again for presenting. For those of you online, you can join another session by going back to the lobby and joining the next one. For those of you in person, enjoy the rest of the conference.